Hello everyone. So we're going to start with your section number 1, unit 1. So now in this class, after you take your 116 class, you registered for this class. This is continuation of your 116 class. Although we're going to talk about different concepts or different materials, everything that you absorb in your 116 class will be very useful in here, especially free body diagrams, vector diagrams, superposition principles that you have learned and used many times in your 116 class should be a plus when you come to this class, because this class is a continuation of your physics 1 class. So all the things that you learn, we're going to use throughout this class, because this material, we start with electricity and magnetism, but still we're going to talk about the forces, add-in forces, vectors, and those things will be still very useful. Okay, so now only thing I need to mention that if you forget about free body diagram, if you forget about vector diagrams, if you forget about superposition principle of vectors, please go to your textbook and review those yourself first week of the class. So then you will be easy to understand what we are doing in this class. Okay, so now let's start with the section. So let's go to chapter 18 is the one that we're going to follow in your textbook. So now in this chapter, it is a long chapter, and I divide this into 2 sessions. That means you're going to get 2 worksheets and 2 homework for your chapter 18. And especially it's very important that although we are following open educational resources, OER resources, we are still should work in with the materials that I think you need to learn to get your learning experience. Sometimes I may add some concepts, sometimes I may remove some of the things and add it into the next chapter and so on, that where that I think it match to learn together, right? So that you need to keep following those things. Electric charge and electric force in this chapter. So you remember in your physics 1 class, you learn about the lot of forces. You start with force of gravity, applied force, normal force, friction force, spring force, and also centripetal force, and so on. So those all forces that you discuss is basically contact forces, but here we're going to talk electric force first couple of chapters, and end of the semester we're going to talk about the magnetic force. These are the 2 forces that we're going to work with. Still these 2 forces are vectors. That's why I want you to know free body diagram, vector analysis before you join in this class. You should have those knowledge. And those are field forces that we're going to discuss, but still your free body diagram informations, vector informations will be useful to handle those vectors. Okay. Okay, so now first thing I'm going to discuss will be basically definition of attraction and repulsion, why charges do that kind of attraction and repulsion, and then we're going to move into the atomic structure, electron, proton, and neutron, and then we're going to move into the Coulomb's law that will explain the attraction and repulsion between 2 charges. And 2 most important thing about the charge is quantized and charge is conserved. So now this is basically physics behind the technology that we are using every day, electric circuit. What is the physics behind that? This is where we're going to start your definitions of those things. Okay. Okay, so now first thing I want to talk little brief introduction about the history. So Ludstone iron 304, after discovery of that material, compass is mapped into the north and south poles by using north and south pole. Compass is built up. That is the first discovery. That is actually not electricity, that is magnetism, right? So compass is a kind of needle that you can point two needles into north and south by using magnets. Okay, and then 1600 William Gilbert concluded that Earth has a huge magnet in the middle. And then 1785, Coulomb, that we're going to learn actually this in your today class, confirm inverse square law is the electric force. And then 1820 discovered that current flowing through the wire can create a compass to fluctuate or deflect. So if I have a current carrying wire, if I keep the compass on my hand, this needle of the compass will be changed when I move around this wire. So that was found in 1830. We also going to learn 1820, that also we're going to learn. And 1830 found Faraday and Henry together discovered independently, actually, they discovered the change in magnetic field can produce the current. So that means current will be able to produce without power supply, but by using the magnets, we can create the current. We also going to learn that end of the first part of the semester about the Faraday's law. And then Clark's Maxwell is the who developed mathematical unification of electricity and magnetism together. That's the mathematical development that we actually have a very unified theory that you are not able to understand. It's a mathematical concept that everything together into electricity and magnetism developed by Clark Maxwell, and that is, we call it as Maxwell's equation that we use every day on all the electronic, all the technology that we are using is basically developed because of those Maxwell equations. So we're going to learn not Maxwell equation mathematically, but we're going to learn those conceptually in your class. And in then 19th century found that superconductors can have 1990 superconductor also happened, but 19th century before that, the magnetism that we have within magnet can be destroyed by heating it up. So magnetism will be destroyed by heating it up, found in 19th century. Later on, that found the superconductivity. Superconductivity is saying that some low temperature, your conductor does not have a resistance at all. Those call it as superconductors that we are still researching on those materials. Okay. Okay, so now electric charges. So now this is, I want to think what you experience in your real life. When you rub a balloon on your hair, and if you try to hang this balloon on the ceiling, it's going to hang in there because there is static charges happening in between wall and the balloon. Because of that, it's going to stay in there. When you try to open your door from outside, you're going to feel kind of static field in your hand, right? Those are the feelings that you already experience in your life, right? The other way you can say that I have two plastic rods that I'm going to rub these two glasses. I'm going to rub this with my hair or with the silk cloth, and then I'm going to bring them together by isolating, not like holding in here as I do. So you need to make it insulating. That means you're going to hang this one and hang this one and bring them together. Then these two going to be repel each other. If you use the one plastic and one glass, then if you do the exactly same thing, rubbing, and then you're going to touch them together, they're going to attract each other. This is what in real life, what we are experiencing, right? So there is no contact between these two objects, but they're going to attract or repel. It's kind of like they have a kind of field that will make that attraction and repulsion, although there is no contact. So that is not magic. It is the field force that will act on these two objects. So we come back to this one to explain why they will attract and repel later. But before that, I want to go to the origin of this electricity. So origin is coming from atomic structure. So we know that the atom has nucleus that will be the center of the atom, that will be the particle of protons and neutrons. They are sitting at the center of the nucleus. They will call it as the nucleus. And then there is electrons around the nucleus, that we call it as the particle, light particle electron. So now if you do something to this atom, what will happen is this electron is light particle and also it is staying outside. That's the only particle that can get out from the trap and do something else, or join with the other nucleus, or do going out, or creating some kind of waves, or that kind of things can happen because of the electron only. Proton and neutrons are sitting at the center. And in addition to that, you guys probably remember about the periodic table. Periodic table show you the symbols, right? And also it will show you the atomic number. Atomic number represent the number of protons, and there is a mass number. Mass number will represent the number of proton plus number of neutron. That's the nucleus mass. Okay, that's the symbol of the periodic table that you will see. But let's say you have the proton. Proton, we're going to call it as a positive charge particle that is in the middle of the nucleus. And then you have neutron, that is a neutral particle, no positive or negative, neutral, that will be also in the center of the nucleus. And then you have electron, that is the negative charge, is staying on the outer rim of the nucleus. Okay, so now what is the neutral means? Neutral means in that atoms are usually neutral. So atom has number of electron equal to number of protons, then positive and negative will be equal. That is, we call it as neutral, right? So now what is the negative charge mean? Negative ion means. So now negative means number of electrons are greater than number of protons. Since the electron has negative charge, then your ion will be negatively charged. And other way around, if number of protons are greater, then your ion is positively charged. That's the definition of positive, negative, and neutral means. Okay. So now electronegativity. Now I want to move into the problem I have. Glass and glass going to repel, but glass and plastic going to attract. Why it is happening? That's because of electronegativity of that material. So that means, as example, glass like to stay with the positive charges, and plastic, I don't have actually plastic in here, we'll say PVC. So going to stay with, like to stay with negative particle. That means some materials like to absorb the electron, some material like to reject the electron. Because of that electronegativity, different material has different kind of electronegativity ranking that will give you the that attraction and repulsion. So now glass will be positive. Then when you have glass and glass, both are positive, they're going to repel. And then plastic and glass, they have positive and negative, then they're going to attract. Now we understand why they will attract and why they will repel by meaning of the charges. Okay. Okay, so now electric charge process, charging process. That means if I have one object which has the charge, I can charge the other object by using three methods. One is the rubbing method. Rubbing method is basically you do not create charges or destroy, because charge is conserved quantity that we're going to discuss later. But when you rub with the some cloth, some material, what happens is there is transferring of electron from one object to another. Then that object is stay with the some charges. As a simple example, if you get the glass, if you rub it on the silk cloths, what happens is negative charge of the glass will move into the cloth, and then your glass going to be stay with positive charge. That is the rubbing procedure that we call it as one of the charging method. Okay, and so now There are other methods that I'm going to come back to that. That two methods are more important than this method that I discussed. The rubbing method is not experimental method that we can observe the charging process, because it is just rubbing the two things together to get the static electric field. So now materials. So everybody know we have conductors, insulators. In addition to that, we have semiconductors, superconductors, topological materials, those kind of materials, right? So to understand what is the meaning of these names, basically it will explain the ability to move the charges around the material, will explain what that material is, what that means. So if I have charged material and neutral material, if I use the conductor, metal is the conductor, what will happen is electron in this material will move into the next one through this path that create in between these two, then they will come to the positive at the end. That material, this needle, is the metal that is the conductor, right? But if you do the same process by using wood or plastic, then there is no ability to move the charges on the wood or the plastic, then that is, we call it as an insulator. In addition to that, semiconductor is the intermediate material between conductor and insulator. Examples are silicon and germanium, that you have most of the chips inside your computer made up from semiconductors. And superconductor is the material, we call it as perfect conductor. There is no resistance to the motion of the particle. Those we call it as the superconductors. Diamond and mercury can be labeled as superconductors. Okay. Okay, so now again, back into atomic structure. We discussed this, we know it. Electrons are sitting outside as an electron cloud. Those are the particles that can do something to your atom, right? So now conduction electrons is the electrons that will basically move around. Protons are at the center, it cannot do anything because proton are stick into the nucleus. Electron is the charged particle that can go around. Okay. Okay, so now charging methods. Now this is the two methods that I mentioned earlier. So first method, we call it as the charge by conduction. Charge by conduction is the first method. Okay. Charge by conduction means basically when you have an object, if you have a charged object and if you're going to touch them together, one object is charged, one object is neutral. When you touch them together, what happens is this neutral object has a negative charges, those will go to the other object and then they will come to the some positive charges. If your object is positive, but if it is negative, it will do opposite. Okay, so now charge by conduction. We'll say I have an object which is a positive object, positive charge. Then I bring the neutral object and touch it. When I touch it, what happens is these two objects going to be positively charged. That is, we call it as the conduction. If I have a negative object and if I bring the neutral object to that, then both going to be negatively charged. That is also called it as the conduction. Okay, so that is the conduction procedure. So now next step is the induction. Induction procedure by meaning, induction means there is no touching each other, but it's going to induce. So what that means is, if I have a positive charge object, if I bring a negative charge, or if I bring a neutral object to here, what happens is there is no transformation of charges, but this object is neutral, it's going to make a, we call it as polarization, going to make positive charges somewhere this direction, but negative charges will going to move closer to the other charge object, which is positive. And then if you connect this into the ground, ground means basically huge object that can absorb the charges or that can emit the charges. unlimited number of charges you can absorb or emit. That's a huge conductor, that is the Earth is. So now when I make this connection, what will happen is this object, the positive charges will stay on the object, but negative charges will try to move into here, right? So now after some time, if I destroy this connection, what happen is your charges will going to stay at positive. That is, we call it as the induction, right? One more time, induction. We'll say, I'm going to make an example in here. We'll say I have an object which is negative charge object, right? So now I have an object neutral. I am going to bring it very close to each other. When I bring it close to each other, what happens is all the positive charges on this neutral object will stay in there, but negative charges will move into all the way to the other side, because positive and negative try to attract, negative and negative try to repel. So now if I ground this wire, ground means connecting to the earth. When I make the grounding of the wire, what happens is this electron will move into the ground until they all move. And then I'm going to cut this wire. Whenever I cut it, this object going to stay only with the positive charges. That is, we call it as the charge by induction. Okay, so now in addition to that, you can have non-conductors. Non-conductors usually do not separate the positive and negative, because non-conductors, they are staying positive and negative together, like your water molecule, they're going to state as a positive and negative together. We call it as dipole. So when you have non-conductor, what will happen is when you bring the charge object, your negative side will be pointing in that direction, positive of the dipole will be pointing on the other direction. Other than that, there is no way you can remove the charges from the non-conductor, because non-conductor is non-conducting material. Okay, so now let's move into the charging by conduction, right? So charging by conduction, simple example is, that means if I have a neutral object, if I have a charge object, positive charge, when I bring these together, I'm going to combine these two. Whenever I connect these two together, what will happen is negative electron of this charge, this object will travel into this one, and then you're going to stay, this one is positive, after travel negative charges into other one. Then after you separate, your object will be positively charged. That is called it as a conduction. If you bring a negative rod, that will do the opposite. Negative rod will create a negative particle on the neutral object. That's we call it as the conduction. So now conduction you will be able to observe by using electroscope. That's the instrument that we can use for the physics demonstration or the laboratories, that will identify the leaves that you have. You have this demonstration in your demonstration video. So I would suggest you go to the extra video link in your Blackboard page and check how this will work. So you have a leaf on the bottom in here. Let's call it as leaves, right? So now I have a conductor in the top. I bring the positive rod into here. When I touch it, electron will move into the other one, and then your leaves going to stay with the positive charges, because you will see that negative is absorbed into the conductor. Then you have only positive charges. That will show you the leaves that was like this going to expand like this. And it will do exactly same if you bring the negative charge, because this electroscope cannot identify negative and positive separately. Only thing it can do is expand the leaves and close the leaves, right? So according to that, whenever they have the charge, it will expand. When they are neutral, they're going to close the leaves. Okay, so now charging by induction, as I mentioned earlier too. So induction, you have a neutral atom, you're going to bring a negative charge as example, then what happens is this positive particle will stay because positive particle cannot move. For visualization, we try to draw it in negative direction, but they don't move. Only thing is moving is the negative particle. So negative particle will move into the other end, and then you're going to ground it. Then negative particle will move to the ground. Then this object is going to stay with positive charge after you remove the grounding wire, and after you remove the your charge rod, your object going to stay with the positive charge. That is, we call it as the induction. So you can do the opposite. You can bring the positive charge, then you're going to ground it, then the electron from the ground will absorb to the neutral atom, then you're going to stay with the negative charge of the neutral object. So that is again the opposite of this diagram, that is also induction. Okay, so now let's move into the point charge. So now again we are working with the point or the particle model or the point charge. So point charge is basically very small charge that we can call it as the electric charge, right? So the electric behavior of electrons and protons basically will define it as the point charges, right? So pre-charge, we call it as electron, usually have the charge of coulombs, this amount. That's the charge of the electron, or charge of the proton. Electron has negative, proton has positive. Other than that, this is the point charge of the electron or proton, magnitude wise. And charge, we're going to measure it by using coulombs. Coulombs is the scientist's name, and that's the unit of the charge. Okay. And so now in our case, we're going to talk about the charge conservation. That means we're going to talking about isolated closed system. That means there is no open system that we can use for these principles. Okay. And so lightning is one of the important thing that we know that because of this charged particle. So now what actually happening in the lightning is, you know that we have in Earth, we have the electron and proton. It's a huge conductor. There is unlimited number of electron and proton. But the air particle that when you have the raining, especially that air particle will basically travel into the low the vapor that travel into the low density media, and then what will happen is you will see that because of that scattering of the particles, what happen is this cloud is basically separated into positive and negative charges. Most of the time the your clouds will have the bottom will have like the negative, and the top will have as the positive charge particle. So now because of this charge separation, then what will happen because of this charge separation, these negative charges I have it in here will try to attract with the positive charges on the ground. Then because of this attraction, it will create the lightning. Then when they attract, it will create the sound. So now lightning comes before the sound, as you already know, because the reason is lightning is basically moving off charges, right? Then when they attract each other, you will hear the thunderstorm. That's the physics behind the lightning and the thunderstorm. And also you probably have seen the lightning in between the clouds, right? In between the clouds also can happen the lightning or also the thunderstorm. That is also possible. This is how the lightning and thunderstorm will work, description by using the charges. Okay. Okay, so now we are ready to move into the Coulomb's law. So Coulomb's law is describing electric force or the electrostatic force between two charged particles, not many charges, only between two charges. If I have two charges, these two charges has attraction or repulsion. That magnitude, not the direction, magnitude given by the Coulomb's law. Coulomb's law describes the electric force between two charges. If I have two charges, Q1 and Q2, those are just labeling. Q1 and Q2. Somebody can say X and Y. Somebody can say uppercase Q1 and Q2. Somebody can say Q and Q. It doesn't matter, the notation, right? So now Coulomb is saying this magnitude between these two charges will be equal to some constant. We call it as the Coulomb constant. This whole thing is Coulomb constant, K, right? That will be equal to the value that I have on the bottom, this number, Coulomb constant in units of Newton meter squared over Coulomb squared. That is the Coulomb constant. That also sometimes we use as 1 over 4 pi epsilon naught. Epsilon naught, we call it as permittivity. That will be this number in the air. Okay. So it doesn't matter you use the epsilon naught, it doesn't matter you use the K, but using K is easier because you have just K to this 1 over this part. So now Coulomb's law saying that force in between two particles will be equal to that K constant times magnitude of Q1 times magnitude of Q2 divided by distance between these two particles and power 2. Right? So this Coulomb's law explains the magnitude of the force only, not the direction. Direction, you need to draw the free body diagram and find it out. So if I have positive and positive, they are going to repel each other. What is the direction of the force is just repulsion force in between these two particles. If they are positive and negative, they're going to attract each other. Then you're going to make the arrows as attraction, right? Okay, so now this Coulomb's law is most of the time valid, but your R, that means the basically distance between two particles should be greater than the size of the particle. That's why we call it as point charges. For point charges, it will work. Okay, okay, that's the Coulomb's law. So now going again to different charges, plus plus. You see that it is repulsion force that we draw in this way. And minus, minus, again, repulsion force. And minus and plus attraction force, right? So that will be the force. So now if you have many, many particles, here one, here one, here one, what you're going to do? Then you're going to use the superposition principle to add all the forces. Right? Because Coulomb's law only works for two charge particles. If you have many charges, you need to keep adding by using superposition principle your vectors, right? So now in addition to that, this Coulomb's law explains very important thing. The force acting on this particle and force acting on this particle will be exactly same. According to Newton's third law, these two forces equal and opposite. Does that two forces change if I make one is greater? We'll say this one is 2 times of the charge. Does your F on one particle different from the other particle? No, still your F is larger because your Q, one of the Q is greater, but still these two forces are equal to each other. Magnitude is different, but they are staying same as always for the two of them. So now superposition principle means you are adding vectors with the directions. Let's call it as the principle of superposition that you already learned. Okay. Okay, so now charge is quantized. That is one of the important property of the charges. What is that quantized means? Quantized means basically charge you can explain by using number of electrons. That means you cannot have half electron. You cannot have decimal number of electrons. That's what it means. That means charge you can always write it as n times E. N will be always a full number, right? That means you can express the charge of any object by using number of electrons. There is no half electrons, that kind of definition. It is called it as the charge is quantized. And so now we talk about electron, proton, and neutron. I don't think I need to explain those again. So charge of these two particles are exactly same, only sign is negative for the electron and neutron does not have charge. And mass-wise, in kilograms, electron is lightest, but proton and neutron has almost the same mass. It is greater than the mass of the electron. Okay. Okay, so now simple example again about the charge quantized. You can have this kind of number, but you cannot have these decimal numbers on the charges. Okay, that's the idea about the quantized. And now charge is conserved. It is similar to the energy conservation, momentum conservation that you guys learn in physics 116. And charge also conserved quantity. That means you cannot create or you cannot destroy. Charge is conserved, right? So now simple example is you can think the annihilation process. That means you have positron and the electron. Then you see that the charges in plus and minus, adding of these two give you a neutral. That means end of the equation, you're going to get the neutral charge. You may experience this in your chemistry class because you are working always with the chemical equation, but your charge left and right should be the same. That is called it as charge is conserved. And pair production process also, you have gamma ray, will create the electron and positron. That also example of the charge conservation. Okay, so I'm going to stop this part in here and we're going to do some problem solving in recitation session by adding pauses, by using Coulomb's law and those kind of things, and do the problems on the recitation session and do the extra problem on your textbook.